Alrighty, welcome everyone to Advent Code Day 3. It is 2 and a little over half minutes left. I am wearing a Santa hat because I just finished playing a hockey game, so my hair is all wet, but I thought this would be nice and festive. Hopefully that means I'm also more awake. I doubt it, but we'll see. But at any rate, base code is loaded up and ready to go. We will grab the input when it starts. We will conquer, hopefully, Day 3. And at the end again, I will try my best to explain my solution. But yeah, that's all I really have. I'm like in a rush. I didn't have as much time to prepare for today. But at any rate, 2 minutes. I will catch you guys when this is about to start, and we will get this problem underway. Alrighty, 15 seconds here. Also, this is like, I guess this is some like underwater theme, given like how these problems have been going. Like the overall theme seems to be water. So I'm guessing it's gonna be some sort of like water, and like this is what the little art's gonna be. But at any rate, off topic. Day 3. Here we go. Let's go ahead and just grab our input real quick and dump this into here, and then we can go ahead and go. The submarine has been making some odd creaky noises, so you ask it to produce a diagnostic report just in case. The diagnostic report. I'm having what is some random sound. Sorry. There's you couldn't hear it, but there's a sound for me. Diagnostic reports consist of a list of binary numbers, which when decoded properly can tell you how many useful things about the condition of the submarine. The first parameter check is the power consumption. You need to use the binary numbers in the diagnostic report to generate two new binary numbers called the gamma rate and the epsilon rate. The power rate, or the power consumption, can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all the numbers the dice report. For example, consider only the first bit of each number. There are 5 0 bits and 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is 1. The most common second bit is 0. Okay. So the gamma rate is this, so 22 decimal. The epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit for each position is used, so that the epsilon rate is the opposite, or 9 in decimal. Multiplying the gamma rate 22 by epsilon rate 9 produces the power consumption 198. There's gonna be some sort of trick with them being the opposites and whatnot, but this is fine. So we can just find one and we'll know the other. Use the binary numbers in your dice report to calculate the gamma rates. Okay. So, so that's one thing to note, is that because they're opposites, we can just calculate one and we will therefore know the other. So we're going to have to go again. The start of this, we're going to go through all the strings. And we're going to have to calculate how many are in each. So we're going to need, what are we going to do here? Let's just do an int array. Again, this you got to do it quick. So we're going to do int array of 1s and 0s. It's going to be, new int array input dot size. We're just going to do 1s and 0s. This time we're going to calculate it. It's going to be kind of whatever. So we're also going to change this to be int I equals 0 while I is less than input dot size. Size. And then I plus plus. String s equals input dot get I. Okay, so now that we know this, then we're going to have to go through each one of the indexes. I guess we didn't need to do that there, but I'm going to copy this anyways. I think we could have actually left this the fancy way, because we don't care about this index, we care about the next index here. And this is actually going to be string.length instead of size. Okay, so what we're going to do here is we're going to then check if the s.get, or it's not, that's char at, right? Yeah, char at index I. If it equals a 0, we will go ahead and do 1s at index I plus plus. Otherwise, we will be doing 0s. Oh, sorry, this is 0s, this is 1s. There we go. This will then increase them, go through, And then the end, we just need to go through and figure out which one is which. So oh, this isn't inputs.size. No. This is input. Sorry, this is actually input dot get 0. It's going to be the length of the binary number, not the length of the input list, because we're only checking the 1s and 0s at each index of the binary, each number of the binary number. So my bad. That's not. That's going to be what it is. So now we got to go through each of the positions in this. We're going to do while 1's dots, the length of that. And now we just need to check for the 1 to 0. So we do need our int gamma and int epsilon, right? I misspelled epsilon. Epsilon. And there's probably a quicker way to do this with the binary, but we're going to do this where we're just going to, because we're going left to right, so most significant is on the left, least significant is on the right. So what we're going to do is we're going to go through them left to right, and what we're going to do is do a check here. If 1's of I is greater than 0's of I, that means we need to do what? Gamma, right? I believe. Yeah, gamma is the most common, so that means it's a 1. So we'll be going ahead and doing gamma, and we need, oh no. Actually, we need to go the opposite way, don't we? No, we can do it, we're good. We can just do plus equals, it's math dot power 2 to the, it actually is going to be the opposite, so it's 1's dot length minus I plus 1, because it's the 0th index. Sorry, this math, I gotta get this math in my head. 2 to that, good. Otherwise, it's the exact same thing, but it's going to just be epsilon. Okay, it's just, okay, it's whatever. And then I think now we can just do a lap of gamma times epsilon, if I'm not mistaken. That's what it's asking for, right? These should be longs, by the way. If I'm not mistaken, let's see. Ah, cool, I got it right. Part 2. You should verify the life supporting rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Okay, both the oxygen generator rating and the CO2 scrubber rating values are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using the similar process that involves filtering out the values until only one remains. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then keep only numbers. Oh goodness, this is about to get crazy. Keep only numbers selected by the bit criteria for the type of rating value or which you are searching at. Discard numbers which you do not match your bit criteria. If you only have one number left, stop. That is the rating value for which you are searching. Otherwise, repeat the process considering the next bit to the right. The bit criteria depends on which type of rating value you want to find. To find the oxygen generator rating, determine the most common value, 0 or 1, in the current bit position, and keep only numbers with that bit in that position. If 0 or 1 is equally common. What? Alright, so I get this part. We only keep 7. Consider the second bit. Oh, then we keep going until there's only one left, and then that's our number we want. Okay. Well, this might get interesting. Okay. So, keep this 1s zeros is important. That's nice to have because we're going to need these again. So let's just go ahead and just do a list. So this is going to be the, I keep going the wrong thing, sorry. We need the oxygen. So this is going to be the oxygen numbers. So we're going to do a new array list, and we're actually going to copy this from input, right? Yeah. It's going to be a copy of inputs. And then we also want the CO2 nums. Also copy of input. Okay, so first, we could do this all in one, but it's not going to work that well. So we're going to do these separately. So so we're going to do a while loop of while oxygen nums dot size is greater than 1. Continue this loop. We are going to need an int index here to control where we are at in our index. Let's start at 0, and then for here we'll go through all of our strings. So for the first index, actually we gotta go through this differently because we gotta go reverse style because we are actually removing them as we go through. So if you're ever doing a for loop where you want to remove an index or remove values from that list as you go through it, you do a reverse for loop, which is to start at the last position. So for int I equals oxygen nums dot size minus 1, and then you go while you're greater than or equal to 0, I minus minus. That way, whoops, I forgot my comma or colon. That way, when you remove something, you're removing it from the end, and then you're going to the next stop. If you were to go the opposite way, if you remove one, now your index is all messed up because everything gets shifted up and into your index, and the length changes and all that. This way is better because you're going backwards, removing them, kicking them out, and just going backwards. Nothing's changing to where you haven't visited yet. At any rate, do this, and then what we can just do is do a check. So oxygen cares about 1s, so it only wants the most common. So again, we want this logic here. If 1s is greater than 0s, and oxygen nums, no. String. This is just the singular oxygen number. I. So if 1s happens more than 0s and this number does not start with a 1, which I guess the char at is 0. So and the char at I is 0. That's fine. Then we want to go ahead and remove it. Remove this index. Good. Similarly, this needs to be an else if, but this is going to be the opposite way around. If they are equal, that also needs to be there. If 0s happen more often, this should catch their equal, and it's a 1. Actually, I should handle both. But that should be all we need. We'll see if this is right or not. But then we're going to do the exact same thing, but instead for the oxygen numbers, we're going to do this for the CO2. What was it? CO2 numbers. Oh, it says C0. It's meant to be a CO2, not C02. Reset index, and everywhere we see this, replace it with that, and this is the CO2 number. And then this one wants to be the opposite way around. Did it care about... if they're equally, keep the values with 0. Oh. Hold on. This is one of these is wrong. Keep the values with 1s. So this one doesn't want equals. This one doesn't want equals. This one does. So if the Ones are more common and it's a 0. Actually, this should be a 1. This should be a 0. This still says that. That goes to that. I think. We'll see if I'm right or not. And then our output is going to be the calculation long. This is going to be the actual oxygen number. I think we can do integer parsant here, if I'm not mistaken. Of the only number that's left, which should be index 0 now. And I should be able to put 2 for binary. I think that works. We'll see. Here's hoping we're right. This will be a miracle if I do this all correctly and I'm right. Nope. I get index out of bounds exception. Okay, this is wrong. Sorry. This is right, but this I is wrong. We are missing I'm doing this wrong. Hold on. I is wrong. This should be index, not I. This should all be index. Index, index, index. I totally made this index variable and then never used it. Good job, me. These are all index, not I. Because we are wanting the index of our binary number, not the index of our list. Try that again. 0 is out of bounds. Oh, but we got here, but we removed all of them. We only want to when we're down to 1. Wait, does it change after every round? Oh, it changes after every round. That's why it's going wrong. Oh. I'm doing all this work up here, but these change every round. So I have to recalculate them every time. Okay, let's chuck this into a method real quick. All right, I didn't know that. Let's return int array. What to do here? This is kind of awkward. Calc. Let's call this calc here. I'm like trying to figure this out. Okay. No, this is not. No. It's not that. It's not that logic. It's the ones and zeros logic. This is what I need. I need to recalculate this every time we do this. Okay, so we need we can just give it inputs. All right, we just give it the input. And this is going to return a new array list. No, it's going to be arrays. Oh, I can't type. Arrays as list ones, zeros. Okay, so what that means is before we do this every time, we need to change ones to be equal. We just need to actually do this. This code is so bad already. Okay. And this is actually making a calculation of the oxygen numbers. And so now ones becomes new calc. Right, I return 1 zeros. I do it backwards, right? Yeah, I do 1 zeros. Okay. And then same thing here, except these are CO2 numbers now. Please tell me I get the right answer. I get 2 and 30. Oh, 0 and 1. My bad. 10 and 23. Oh, there we go. Okay. Reset this back to our input. Calculate it. We get this as our number. Submit it. We got it. Oh, I'm so sad. I had that the whole way. I didn't understand that they changed it on the second one. That's unfortunate. Well, okay. So got in the end. I was actually right in the first try of this stuff, the second part, but I didn't understand that I needed to update those ones and zeros, and that's what killed me. I spent so much time debugging. Unfortunate. And I'm probably sure you can probably see like on the leaderboard for my personal yeah. Not good. But anyways, let's get to explaining what this is and how this works, shall we? Now that I know this is how this is done. This code's a mess probably, but let's also go ahead and just do part 1, part 2. Part 1. So the TLDR of this is that, or the TLDR of this question for today is that you're given this big long list of binary numbers. And through these binary numbers, you need to calculate some diagnostic numbers through those. The way that the first one is the diagnostic number of this gamma and epsilon. The gamma is, if you look at your column, or if you look at all your binary numbers and you take the very first or the most significant number of every binary number, which is the leftmost in this case, if you look at all of them and you calculate how many zeros there are and how many ones there are, the gamma number will have the one, or the one that happens more often in it. The epsilon number will have the one that happens less often. So basically, you're taking all these binary numbers and you're creating 2 new binary numbers from the values in this. So you repeat that process for every index or every number in your binary number, basically creating the gamma number, but the gamma binary number being the most significant digit in every column, and the epsilon number being the least significant digit in every column. I'm sure there's a more mathy way that this can be calculated. I don't know it. So this is just my quick code that I did because I don't have a lot of time to try and research or think about it. So at any rate, my part 1 is just to go through, calculate how many ones, how many zeros are at every single index, or at all of the indexes of all the binary numbers in our list. And then from there, go through every index and create our new gamma and epsilon numbers based upon which one has more and less. So that will give us our very first part. For the second part, it is similar in that we are building up, is different that we're not building up a number anymore. We are trying to find a number that fits this pattern, I guess. So using that same idea as the first one, where we find how many zeros, how many ones there are each index of a binary number, we use that to then find the number that matches the pattern. For the oxygen number, we take the number that is most significant, and if the number in our list does not match that, we kick it out. So say like the most common for this first index is a 1. We go through and we keep only the numbers that have a 1 in the first column. We remove all the others. So as we go through each step, we remove more and more numbers from our list, and eventually at the end we will have a list with only 1 binary number in it, and that is our oxygen number. And then you do the same process for the CO2, but doing the opposite. So if there is a 1, if the ones are most significant or happen more often for this index, we want to take the zeros instead, so we remove all the binary numbers that start with a 1, and then again continue that process of each index, removing all the ones that don't, or that have the least significant, or not least significant, the least common digits in it, and going through that way. The only trick to know is that you have to recalculate these ones and zeros, or recalculate how many ones and how many zeros there are every time you go through that list. That's what I messed up. But at any rate, yeah, so hopefully that explanation was a little bit better. Not, we'll see. But anyways, that'll do for day 3. Hopefully your day went better than mine did, but at any rate, thanks for watching. I'll see you guys tomorrow for day 4. Peace out.